Okay, good morning everyone. We're coming live from you from London. This is Dave Pike from RS Components, aka Connector Geek, and I'm Pete Wood from Design Spark, RS Components engineering community. So, thank you for joining us today for our Hangout with Harting. We're going to be talking about understanding the link between Industry 4.0 and the connected world. So, just a bit of a background on Harting. Harting are a world leader in industrial connectivity, and they've been designing leading edge products for 70 years now, in fact 70 years this year. And RS Components have been working with Harting for 30 years, and we're now their leading global distributor. So our speaker today is Gavin Stoppel. He's the Smart Networks Infrastructure Applications Manager at Harting. Gavin's been with the company for about 9 years, exploring the world of RFID and smart technology. And Gavin is pretty much Harting's resident Internet of Things, so we're very lucky to have him today. He's had 30 years experience in industrial automation, control and industry, including product management, marketing for electrical distribution solutions, and smart technologies, which include rugged networks and, more recently, UHF RFID solutions. So, thanks for joining us today, Gavin, and I'd like to hand over to you to make your presentation.
Thank you very much, Dave and Pete. Yes, I'm the resident UK Product Applications Manager for all things smart technology-wise within the Harting Group. In particular, I cover things like the rugged network solutions as well as RFID solutions and applications. I'm going to be running through a short presentation very shortly, just looking at the connected world, Industry 4.0 and IoT. Yeah, so bear with me while I get the presentation started. So yes, so what IoT and Industry 4.0, revolution or evolution? And what we're going to be looking at is a very brief overview and discussion of where we come from and where we're going to. Certainly, the basis of the Industrial Revolution starts way back with Industry 1, as it were. So replacement of manual labor, mechanization, and mass production using steam. Industry 2 was the development of mass production with the electric motor at its heart, and also the development of the internal combustion engine. Moving on to Industry 3 was the development of the digital age and communication with advances in electronics and information technology, which then leads us up now very much into the current day with the development of Industry 4.0, defined as represents the networking of embedded items with intelligence, making passive items smart items. These smart items are able to connect, share, and transfer data and allow communications irrespective, and this is the really important thing, as I mentioned briefly earlier on, irrespective of manufacture, environment, and application. So, what is integrated industry? We talk about the emancipation of field devices, or big data and seamless intelligent connectivity. And the basis for integrated industry is this seamless connection between all elements in a manufacturing process. Manufacturing environment, and certainly that goes right from the field level through to the control and right through into the management level as well. And of course, really, and I think what everyone tends to miss the point slightly is when we talk about Internet of Things, we talk about big data, and it's the transfer and the communications of these items right from the field level and the seamless data transfer right from the field right to management as well. And of course, the big thing here is very much is that certainly some of the proprietary current field bus systems do not always allow for this. And also they need to allow for the transfer of analog and digital values that typically come from a manufacturing environment. So if we then move on, what are the technologies currently that are driving this integrated industry and the Internet of Things? I mean, networks very much are a key point to the development of a cohesive communication structure. Now, those networks can be either one or a number of different technologies. So moving from Ethernet, typically at the moment, and that Ethernet can be industrialized version of proprietary protocols, right through to RFID, Wi-Fi, Bluetooth, and of course even GSM modem technologies as well. Here we talk about very much as well as the miniaturization and modularity of intelligent sensors at the field level and also transponders. So items that will be able to transfer information about not just the not just the product itself, but also its environment from the field into the management level. And of course, the development of things like energy harvesting systems and solutions, solar, wind, we see prevalent very much these days, but also the development of thermal and also very much kinetic systems and solutions as well. However, and I'll go back to this right in the beginning as well, is that there's very much is the basis for really sound network solutions. And we talk about data speeds. I mean, going back many years, 10 megabit per second was deemed as very fast. Now we, as a standard, operate a gigabit, 10 gigabit, with 40 gigabit down the road, and even moving into terabyte transmission speeds as well. And the base for this very much is looking at copper and fiber-based solutions. So, copper and fiber these days as a means of data communication, certainly big data, is very low cost. It's relatively easily installed, and of course the best thing here is it's easily maintained as well. And I'll cover one or two of these products a little bit later on. So we've got so far, but what can go wrong? I mean, there are a number of pitfalls here. And certainly, as I already alluded to, is proprietary standards for communications and controls between different manufacturers and suppliers of equipment, so be it automation or passive devices, even active devices within a controls environment. And typically at the moment there are a number of wide manufacturers that offer a wide variety of proprietary communication methods. However, the medium for this very much is based on a twisted wire cable, as it were. The next thing here, which I believe as well, is failure to view the increased data requirements as part of the seamless transfer of data and information. Very much having a system in place at the moment running at 10 megabits, and you haven't thought about the increased data requirements in any environment can be a very limiting factor. Of course, as well, failure of IT to adopt changing requirements between manufacturing and commercial platforms. I think we see this quite often in manufacturing environments where your controls platform and your commercial platform don't always meet and don't always have the right communication structure in place, and this can play a big part in limiting this development to integrated industry. Limited expansion capabilities on the control platform in manufacturing and IT. Well, once again, is that not taking care of development for the future. So putting in technology that for example, you'll require higher data requirements into the future can be a limitation. So putting together a cohesive plan to increase your network capabilities is a very sound practice right at the beginning. And of course, one thing, the most important thing I think in any system these days, and we see this a lot happening, is cyber attacks from external sources, and this can really challenge implementation of not just a coherent security platform, but also looking at how you develop the development of internet integrated industry and the Internet of Things. So the system. I've tried to give a simple representation of how we view a Internet of Things system, as it were. So the beating heart of any system would be your physical world, the physical cyber world, as it were. So the Internet of Things, and feeding into the Internet, or the body, as it were, is you have veins, arteries, and muscles. The veins, arteries, and muscles, as we know, give you the sight, smell, hear, taste, and touch. Now you can equate that into a control system. So developing that is that your veins, arteries, and muscles can be your power, signal, and data into any system itself. So here we look at then is the sensors, as it were, into any control system. So color, temperature, pressure, flow, on/off signals, as it were. What that really equates to for us then in automation is your automation systems. So vision recognition, sensors, PLCs, RFID, robotic solutions, to name a few. Now, digital transformation. So adoption of new technologies. This is really interesting, I find, is that when you look at the telephone, around about 1876, it took 75 years to reach 50 million viewers. Well, users, I should say. Looking through to Angry Birds, 35 days, December 2009. And that's an incredible adoption of the Internet of Things. Cisco, for example, predict that by 2020 there'll be 50 billion things connected to the Internet, and currently we're talking about 25 billion. That's an incredible development. So where does Harting fit into all of this? Well, for us, it's very much about power, signal, and data. And we then have different solutions and different capabilities within Harting to be able to make this transition very easy to take your field devices right through into your control and into the management levels as well. Power, signal, and data. So yeah, typically we talk about your 400-volt power supply, 230-volt. We talk about your 24-volt signal control voltages, and data communications. Now this can be even anything from proprietary field bus solutions even to Ethernet, and then utilizing a multitude of different media, as it were, to be able to do that. Now, if we look at the multi-layered approach from Harting, as it were, is that right from your field level, so your sensors, actuators, through to I/O terminal interface machine units, machine-to-machine interfaces, and interfaces into the factory itself, you will find that we have a wide range of products, and I'll show you one or two of these going forward as well, that has the capability to be able to easily implement a cohesive strategy to take care of your power, signal, and data communications. So, looking from the Internet of Things cloud, as it were, downwards, for us it's the development very much of auto ID systems and solutions. So, looking at things like RFID, looking at your passive and active, low-cost network solutions, and right through into the future into things like smart power networks. So things like being able to monitor your power usage live, right down into machine level. And further on from that is very much the development into very, very simple, easy, low-cost terminations that you can use to expand and extend your data requirements within a network itself. Right through to our hand modular range as well. And the hand modular range is a great tool in that very, very simply you can take a connector and actually very easy add different modules to this connector to allow for your power, signal, and data requirements within that development of that solution. Right through to intelligent modules as well, and this includes things like data storage in ID modules to allow you to be able to differentiate between different machines and different connections that you can have in a controls environment. So, essential. Interfaces are going to be a very key factor going forward, because all elements in a production process, we're talking anything from machine modules, workpieces, tools, should all be connected with each other, and in many instances must be connected with each other. The number of data connections between different levels and direct interfaces between machine, modules, etc. in the production line will increase. So as you develop going further into a Internet of Things environment, you still need to have those field connections, and as the data requirements go up, you will find that you will increase your power, data, and signal needs. And this is definitely an evolutionary process, because current machinery, and that's existing legacy products, within the existing environment, you must be able to connect and migrate to the integrated industry. So, Industry 4, the fourth industrial revolution, the Internet of Things. This is very much a driving force behind a fundamental, far-reaching shift. Innovative products and services and structures are emerging. Industry is becoming the integrated industry. Harting and RS Components are accompanying you on this path. Thank you.
Great, thanks, Gavin. Great presentation. I particularly love your slide around lots of technologies. That was really interesting. So we're going to open the floor to questions. We've had a couple come in already. So what we'll do is I'll hand over to Dave here, and we'll read the questions out to you, and we'll take it from there. So over to you, Dave.
Certainly, thanks very much. Yep, The questions we've had through, there's a couple of specifics, but lots of the questions we've had through kind of revolve around two things. One is, how easy is it to install or integrate Industry 4.0 technology into an existing situation or a brand new one? And the other one would be the benefits brought to maybe small to medium-sized companies. We've seen things on TV recently about how things like RFID tags and this kind of stuff can be used within, say, a car manufacturing plant. It's a big industry, but there's obviously lots of people out there who are interested about how this type of technology could benefit them. So I suppose the first question to ask is, how easy is it to integrate Industry 4.0 technology into an existing process?
Yes, thank you, Pete. Certainly, the development of the existing technology and utilizing legacy systems does make it very easy. I mean, simple things, for example, in utilizing low-cost connections. If we talk about an RJ45, for example, very well tried and trusted means of communication. But strangely enough, in that environment, it does mean that the reliability of an RJ45 is very, very key. And utilizing, for example, an IDC, very toolless type connection, it takes you less than 2 minutes to connect and terminate and be up and running very, very quickly through into low-cost DIN rail mount solutions in the form of small unmanaged Ethernet switches. Allows that integration to be very, very simple. Certainly going forward into your power, data and signal and having a wide diverse range of different connector solutions does enable it very simply to be developed further.
So it's fair to say that quite a lot of this technology is going to be plug and play.
Very much so, very much so. And the simpler manufacturers make their products and ease of use makes it very easy for an end user manufacturer to be able to implement the starting process. You don't have to go out and start to develop a massive big, a massive big philosophy, as it were, into how you connect things and the infrastructure. Starting very simply, starting right down at the basic level means that you can slowly develop and increase your data requirements and put in different control solutions and interface systems and that sort of thing. You don't need to drive straight into the Internet of Things and have a cloud-based solution to start off with, because obviously the development of that can be costly in the long term.
Okay. We've had a question, Gerhardt's asked a question specifically around, he said that his biggest challenge is using the GSM network. And he's asked, have we got any suggestions for things like GSM modules for microcontrollers? But is GSM something that, again, is it easy to integrate?
Yes.
This kind of equipment.
I mean, as part and parcel of this, I mean, GSM is, along with Wi-Fi solutions. I mean, certainly Wi-Fi on a short range, as it were, is very competent. But certainly from a GSM perspective of a much longer distances. There's a wide range of different manufacturers out there that do support standard GSM solutions, as it were, that can be easily integrated into existing control systems.
Interesting. We've had a couple of questions from people who aren't really aware that the Internet of Things has an application in industrial use. A lot of people are saying, isn't it just for turning on my central heating with my iPhone? So this is a key thing. I think, Pete, you've got a question around that.
Yeah, I mean, just based on your side around the adoption of new technologies. I mean, industry tends to lag behind the commercial world. I mean, how with the world that we're living in now, with everything getting connected, is industry behind the curve when it comes to commercial applications, or is industry right on the money right now? Right on the pulse of it.
Yeah, I mean, certainly industry is right on the money, and certainly from Harting's perspective is that we're developing new solutions all the time. Certainly the development of our active RFID application solutions at the bottom end, does mean that into the industrial environment it makes it a lot more cost effective. I mean, we all know, for example, RFID has been around for 20 years and has been used in retail applications quite extensively. And that tends to be relatively low cost. However, when you start to look at the development of products into an industrial environment, there's a lot more punishment that happens with these products. Certainly things like temperature, shock, vibration, noise, electrical noise, etc., can play a big part in disturbing data transfer as well. So industry is slightly behind the curve of what happens in the commercial retail market, but purely because of the adoption of rugged technology, as it were.
Okay.
Thank you.
Something else that someone's picked up on in terms of your presentation, we were talking about proprietary standards, the kind of the communication standards that various proprietary bits of kit are using. I think one or two people are concerned they're going to have to relearn how to program, or they're going to relearn how to use software. What are the pitfalls around that? And is there a universal protocol on the horizon? Is this something people can look forward to?
Certainly the adoption of the IEEE 802.3 Ethernet standards, as it were, means that a lot more manufacturers are coming on board, and maybe not just offering their own proprietary standards, but also adopting the IEEE 802 standard as well. However, a lot of this supports the same medium. So you'll find a lot of networks, as I mentioned earlier on, will typically use your standard, RJ45 communications capability as a hard connection, as it were. And the further adoption of standards with regard, programming environments for PLCs and that sort of thing is being shared more and more across the board. So from an industrial perspective, it's becoming a lot easier, and certainly in my time over the many years in the industrial environment, I've seen a shift into the development of sharing of devices that has multi-protocol capabilities, as it were. And certainly from an Ethernet switch perspective, you'll get Ethernet switches now that will support everything from Profinet through to Modbus TCP, TCP/IP, and even right down into the building environment, utilizing things like BACnet communication capabilities. So very much a sharing of information is key going forward into the Internet of Things, and the ease of adoption of various standards from different manufacturers makes the sharing of that data a lot easier.
Okay. We've had another question from Gerhard, actually, and he's mentioned Google Brillo. It's not one I know. Is this something you're familiar with?
No, I must be honest. I haven't really come across that myself. I will certainly look into that a little bit further.
Brillo and Weed, it's basically I think a Google IoT kind of application environment, if you like, for creating applications. So
it touches on what we were just talking about, the idea of some kind of standard interface to allow people to integrate and program easily. It's just interesting that somebody's brought that up, who are genuinely interested in how this will work with their existing and with new systems.
I think this really does. That's actually quite interesting, because certainly the development of all the new technologies and the new programming environments, and that makes it very easy then to be able to start to develop field solutions into the cloud, as it were. And I think, to be perfectly honest, I think we'll see a lot more of this coming up, certainly from a lot of the major software companies that are out there as well. Just the development this weekend, I was offered a very simple means of controlling my gas usage in my home, and the guy that offered to me didn't realize that it was the Internet of Things, and the whole thing was based in the in the cyber world, as it were. So very interesting in the developments going forward.
Actually, that touches on the question of applications. We're talking about a domestic situation, as Pete mentioned. The domestic applications for Internet of Things certainly have caught a lot of people's imaginations in the short term. For no reason, everybody's got one of these now, and they can control their home from their phone. But looking at industrial applications for small, medium businesses, I was really interested in what you're saying about how a company can start small if nothing else, say tagging their inventory system and then building up from there. Have you got any examples or any information about those?
Yeah, and certainly for Harting, I mean, this is an area that we're moving into quite extensively right now. Is I mentioned in my slide auto ID solutions. So looking at a very simple way to be able to read inventory, as it were, but bearing in mind that we've moved from a retail environment into an industrial environment. So, for example, if you now take and require an RFID transponder for sort of field level, I mean, this is quite a large one, as it were. However, this is a very rugged smart label. This smart label itself has the capability of being read anything up to 10 meters, and it will cost you less than €1. But also, it's got built-in memory capabilities, so you can write additional information down to that. Now, we can go from something that size, which has a fairly sort of rugged, hardy capability, but fairly low temperature, into a product that looks like that. Now, that itself is a very rugged little RFID transponder. It will, for example, survive in excess of 210 degrees, 50G shock. So very rugged, very low cost to start off with. Now, you're taking that and utilizing things like UHF technology, which in itself is relatively low cost, with a RFID reader, and then interfacing that into the physical cyber world, as it were, is relatively easy and relatively low cost. And you start small. And certainly the development of, as I mentioned earlier on, of the retail industry is driving very much into the ruggedness of technology for industry right now.
And this is the sort of thing that people could integrate to their existing. The idea of, say, a smart inventory system tagging the inventory as it comes in and out, or the machine tools as they get booked in and out for use. The sort of thing that people could integrate very quickly. Without any hesitation. And for Harting, I mean, we even try and make things as very simple as possible. And the development of utilizing RFID, we've even developed an RFID development kit, which makes it very, very simple and all in one. So, and low cost. So you start off small and you grow and you develop your application very, very quickly, as it were, without expending lots of money. Fantastic. I think that's all the questions that I've got so far.
Yeah, if anyone's got any questions and you're watching live, feel free to leave them on the YouTube page, and we can pick those up right now. So we'll give that a couple of seconds. So yeah. Just recapping on some of the things we've heard over today. So thanks again, Gavin. I've got a question actually around security and security of data. I mean, what are Harting doing to address that big topic of security, which seems to be one of the biggest concerns, I think, for anyone who's implementing an IoT application?
Yeah, there is, as part and parcel of any IT system, there's a wide range of different secure systems and solutions that are available. I mean, for us, if we're talking about the transfer of and security of an RFID tag, for example, you can even password protect these tags, so no one can come along and overwrite the information within those tags. Typically, though, is that when you start to look at that, you then move up from a standard 5-port unmanaged switch into the higher levels of network solutions that start to have very much built-in security in mind. So things like IP address recognition and those sort of levels can be developed further into upper devices as well. And we have those solutions in many instances. So.
Okay, cool. So it looks like we have no more questions. So I'd just like to again thank you, Gavin, for excellent presentation, and for everybody who took part and listened today. We're going to post up this on RS YouTube, so that will be up there. I think almost immediately. I think after the broadcast is finished, so you'll be able to go and review that and point your friends and colleagues at it as well if they've missed it today. We're also going to be hosting some content on designspark.com. where you can also find lots of other articles around IoT, Industry 4.0, lots of articles from Harting that we've done together. And also, of course, if you visit the RS website, there's thousands of Harting products there you can peruse through and select. If you've got any questions, again, please tweet us or leave questions against the YouTube video or onto Design Spark, or email us wherever you feel best fit. So I'd like to thank everyone again. Thank you, Gavin, and it's goodbye from London, and thank you again. Bye.